Welcome to integration by substitution. So integration by substitution, we've seen before that the reverse chain rule is actually a really clever way to integrate, but it doesn't cover all situations. So this is why we need in extension, we use a form that's, or substitution that's in the form of u equals f of x. For extension one, the substitution that's required, it will actually be given to you in the question. And now the integral will be with respect to u. We can replace the u with the original substitution if it's an indefinite integral. We have to, replace. Whereas for a definite integral, we can change the integral values from the x values that are given to us to the u values using the substitution that's given. So we'll have a look at a couple of questions and how that operates. So we're going to use the substitution of u equals x squared plus 1. Now for the first one, we could actually do this using the reverse chain rule. Actually, we could for the first two, but we're going to show it so that we demonstrate what's actually taking place and how it operates. So the second and third ones are from past HSCs. So with the first one, so we're using u equals x squared plus 1. So when you differentiate that, so differentiate u with respect to x, you get 2x, and du is equal to 2x dx. So that's what we're going to replace in the integral. So notice that underneath the square root is x squared plus 1, and that's going to be replaced with the u, that's the blue, and the yellow, so that whole 2x dx is actually du. So we're going to integrate the square root of u du. So we know that we write the square root of u as u to the power of a half. So that becomes u to the 3 on 2, and out the front is 1 over 3 on 2. And then replace the u with the substitution, which was x squared plus 1. So you get 2/3 square root of x squared plus 1 cubed plus the c value. All right. Second one. Now for this, to make it easy, because we're actually going to integrate with respect to u, we're going to actually find the u values to integrate between after we've done our substitution. So u equals x squared plus 4. The derivative of that is 2x. So du is equal to 2x dx. Now you notice that we've got a fairly close substitution. We're just going to need a 2 on the top. So on the numerator, we're going to need a 2x. So we know what to do in that case. I'm not going to come back and replace the integral I get in terms of u with x values. So I'm going to use the substitution. So when x is 0, that's the lower part of the integral, u is 4. And when x is 1, that's the upper limit of the integral, u is 5. So we're now going to integrate between 4 and 5 when we do our substitution. So the original needs a 2x on the top, so we put a 2 on the top and a half out the front. And notice that what I've done is when I change the integral with the substitution, we now go from 4 to 5 because we're now integrating with respect to u. So we get 1 over the square root of u, which is exactly the same as what we did before. So that becomes u to the minus a half. And u to the minus a half integrates to u to the half, and we get 1 over a half. So substituting in, you get the square root of 5 minus the square root of 4, or the square root of 5 minus 2 as an exact answer. So for the other one, integral from 3 to 4 of x plus 2 square root of x minus 3. Now this is one that you can't do the reverse chain rule, so the substitution has to take place. So they're giving you a u equals x minus 3, so we know that's the blue section. But the little green section that I've got where it's the x plus the 2, the x is going to have to be replaced by rearranging the formula to get x by itself. So let's go back, let's do u equals x minus 3, differentiate it. So du dx is 1, so du equals dx. So the dx is just going to be replaced by du. and we're going to change our integral values. So the 3, substituting that in, you get 0, and substituting 4 in, you get 1. So we're going to integrate from 0 to 1 of u plus 3 plus 2. That's the green section. That's replacing u, the x with u plus 3, and the square root of u du. So that integral of our x with the replacements becomes the integral from 0 to 1 of u plus 5 times u to the half du. Expanding your brackets, so it makes it easier to integrate. So that becomes u to the 3 on 2 plus 5u to the half. When you integrate that, you get 1 over 5 on 2 u to the 5 on 2 plus 5 times 1 over 3 on 2 u to the 3 on 2. And we're going to sub 1 and 0 in. So we get 2/5 plus 10 on 3, and that's equal to 56 over 15. Right, let's have a look at some harder ones with trig substitutions. So these are from past HSCs, and trig and harder ones with exponentials and logs. So for the first one, once again, because it's between values, I'm not going to try and you get an answer and then try and get the substitution back. But if I differentiate, so if u equals cos squared x, remember we can make that cos x all squared. So the differential of that is minus cos x minus 2 cos x sine x. And we know that's our expansion of sine 2x. So we get minus sine 2x. So we're going to need minus sine 2x on the top. And that we can then replace. And we're going to replace, obviously, cos squared x with u. So we get, we're going to know when x equals 0, u equals 1, and when x equals pi on 4, u equals a half. Now you'll note we're going to go from 1 to a half in this case. That is legible. Just make sure you're consistent. So where the 0 was, make sure u equals 1. And where the pi on 4 is, make sure you make u equal to a half. So our integral becomes minus 1, the integral from 1 to a half of 1 over 4 plus u. That becomes a log when you integrate it. That becomes minus ln 4 plus u between 1 and a half, which becomes ln 4.5 minus ln 5. Obviously, multiplying by the minus, you get ln 5 minus ln 4.5. And when you subtract, you can divide after the logs. So you get ln of 10 over 9 as an exact answer. Use the substitution of x cubed plus 1 for u. Differentiating that, you get 3x squared. Now, once again, we need a 3x squared, so we're going to put a third out the front. When x equals 0, u equals to 1, and when x equals 2, u equals to 9. So we're now going to integrate from 1 to 9. So we get the integral from 1 to 9 of e to the u with a third out the front. E to the u integrates to e to the u. Subbing in 9 minus subbing in 1, you get a third outside of e to the 9 minus e to the 1, once again as an exact answer. Final one, u equals log e to the x. So, and our current one goes from e to e squared. So when you sub in x equals e, you get 1 for u, and when you sub in x equals e squared, you get u equals 2. The derivative of log ex is 1 over x. So du is equal to 1 over x dx. You'll notice that everything's replaced. So we now get the integral from 1 to 2 of 1 over u squared. That becomes the integral of u to the minus 2, which is minus u to the minus 1 between 1 and 2. Substituting the 2 minus substituting in the 1, and you get the answer as a half. Thank you.